Okay, let's talk about ratios and proportions. And hey, before you have some kind of flashback to high school math class, I want you to think of them as a practical superpower, one you're actually already using every single day, probably without even realizing it.
See? I bet you have. If you've ever doubled a recipe because you had more people coming over, or tried to figure out which TV screen has the right dimensions for your wall, then you've already used ratios and proportions. You're an expert. Today, we're just going to give that intuition a name and a really powerful framework. So let's pull back the curtain a little and put some official names to these tools we're already using. We're going to start by breaking down exactly what a ratio is, what a proportion is, and how these two things work together hand in hand. First up, a ratio. It's really just a simple way to compare two things. Imagine you've got a fruit bowl with 2 apples and 4 oranges. The ratio of apples to oranges is 2 to 4. And just like a fraction, you can simplify it. For every 2 apples, there are 4 oranges, which is just another way of saying, for every 1 apple, there are 2 oranges. That's a 1-to-2 ratio. That's it. And this is where proportions come in. They build directly on that idea. A proportion is simply an equation that says, hey, these two ratios are equal. So, that 1-to-2 ratio we just talked about, well, it represents the exact same relationship as a 5-to-10 ratio. When we write that out as an equation, 1/2 equals 5/10, boom, you've got a proportion. It's a perfect statement of balance. This little table breaks it down perfectly. The best way to think about it is that ratios and proportions are like two faces of the exact same coin. A ratio is the comparison itself, like 3 to 5. A proportion is the full equation that shows two of those comparisons are actually the same, like saying 3 to 5 is the same as 6 to 10. One is a statement, the other is an equation. All right, now for the part I am really excited to share with you. This is the secret weapon. It's a simple little trick that just cuts through all the confusion of those word problems and turns them into something you can solve in your sleep. Seriously.
This is absolutely brilliant, and it came from a user online. It's so simple, it's almost genius. To turn any ratio into a fraction you can actually use, just add the parts of the ratio together. That sum, that's your new denominator, the total number of shares or parts. So in a 7-to-2 ratio, there are 9 total parts. This one little step, it changes everything.
So here's how you make that trick a repeatable process every single time. Step 1, grab your ratio. Let's say it's 2 to 6 to 1. Step 2, add them up. 2 plus 6 plus 1 gives you 9. That total of 9 becomes your denominator. So, step 4, your fractions are just 2/9, 6/9, and 1/9. How easy is that?
Okay, theory's great, but let's put this thing into practice. It's time to take our new superpower out for a spin with a few classic problems. Let's see it in action. Here's our first challenge. The recipe's ratio is 2 to 6 to 1 for sugar, flour, and salt, and we want to make a total of 21 cups of dough. So, the question is, how much sugar do we need? Take a second, how would you start? And here's how we solve it. First, we use our trick. Add the ratio parts. 2 plus 6 plus 1, that equals 9. So sugar makes up 2/9 of the total recipe. And what's 2/9 of 21? Well, it's 42/9, which simplifies down to 4 2/3 cups. See? Easy, right?
Okay, next up is a different kind of problem. This one doesn't really need a calculation, it just needs a little bit of logic. We've got a 3-to-8 ratio of white to brown socks. So which one of these numbers could possibly be the total number of socks in that drawer?
And the key is our exact same trick. The ratio is 3 to 8. So what's the total number of parts? Well, 3 plus 8 is 11. Now, since you can't have half a sock, the total number of socks has to be a multiple of 11. And if you look at our options, only one of them, 44, is divisible by 11.
Let's try one more. This one's a little trickier. There's an extra step. We know what Rohan and Anish earn, and we know what they both spend. To find the ratio of their savings, we've got to do a little bit of work first.
So the crucial point here is that you can't compare their savings until you actually know what their savings are. So first, you have to calculate it. For Rohan, it's 12,000 minus his spending, which leaves 2,040. For Anish, it's 15,960 minus his spending, which is 6,000. Now you can make your ratio, 2,040 to 6,000, which simplifies all the way down to 17 to 50.
That process we just used, where we found the value for each individual person before comparing them, that actually has a name. It's called the unitary method. It's this really fundamental technique where you always find the value of a single unit first. We found Rohan's savings, then we found Anisha's savings, and then we made our ratio.
So, we've pretty much mastered ratios for static, fixed problems. But what happens when things are changing, when they're in motion? Well, that's where proportions really shine. They help us describe the dynamic relationships between things all around us.
And there are really two main ways quantities can relate to each other. In a direct proportion, they move together. Think, the more workers you put on a job, the more work it's done. But in an inverse proportion, they move in opposite directions. The faster you drive, the less time it takes to get there. It's actually a pretty elegant way to describe cause and effect.
Okay, so we've defined the terms, we've learned the tricks, but what's the big takeaway here? I mean, why should you actually care about any of this stuff?
Here's what it all boils down to. Ratios compare things. Proportions show when those comparisons are equal. And that simple fraction trick, just adding the parts to find the total, that is the key to unlocking almost any ratio problem you'll ever see. You combine that with the unitary method, and you're pretty much unstoppable.
Ultimately, this isn't just about math. It's really the language of relationships. You can find it in the harmony of a musical chord, the perfect balance of ingredients in your favorite food, and in the blueprints for the buildings we live and work in. Ratios and proportions help you see those hidden connections everywhere. So the only question left is, now that you have the tools, what will you use them to understand next?